So we are going to have a look at solving relative motion problems, basically just crossing a river when there's a current, but it also can be applied to a lot of different scenarios. We have, let's lay out the situation. It says we have a cat that's been thrown across the river, and the cat has an ability to swim at 2 meters per second. The river itself is 802 meters across. The cat can swim 2 meters per second in any direction. The river itself is flowing at a rate of 1.5 meters per second. So what we need to do is we need to set up resultant vectors or simple vector addition. So the way these arrows are set up are not that helpful. So the cat is going to be moving from right to left at 2 meters per second, and she's going to be moving down at 1.5 meters per second. So this is the velocity of her swimming, this is the velocity of the river, so Vs and Vr. And the actual velocity, or the resultant velocity, will be the vector sum of both of those. Now the convenient thing is that we have a right angle. So when we are doing relative motion questions, specifically like this with multiple dimensions, we always remember that each velocity only acts in its independent plane. So the velocity of the swimming, left to right or on the x-axis, will only factor in to the horizontal direction they move. The velocity of the stream, north to south, that will only factor in with how far down the cat is pushed down the river as she tries to cross. Because as she tries to cross, the river is going to push her, and she's not going to be able to end up directly across the river. She'll end up somewheres over here. So we'll keep coming back to that question. But the first part we look at is how long, or how, in seconds, how long will it take the cat to swim across the river? So this is a horizontal problem. So we have velocity, distance, and time in this case. There's no accelerated motion, so this is uniform motion as she swims. We know that she can swim at 2 meters per second horizontally. We know the distance is 802 meters, and we are being asked to find time. So since velocity is equal to distance over time, or displacement over time, speed is equal to distance over time, we know that time is going to be equal to distance over velocity. So that's 802 meters divided by 2 meters per second. And that's equal to 401 seconds. We only have two significant digits in the question, so that's equal to 4.0 times 10 to the 2 seconds. Uh, 401 is a completely acceptable answer, but when we are enforcing significant digits in our measurements, we definitely will be moving to various forms just so we only have two significant digits. So it's going to take her 401 seconds to get across the river, and during that time she's going to be pushed downstream. Now question B says, how far down the river will the cat arrive on her original shore? Well, we need to figure out what this distance is, and the only velocity that's going to affect that is the velocity of the river, or Vr. So once again, I have V, D, and T. I know T is 401 seconds, we just solved that. But now we're going to use the velocity of the river, and that's 1.5 meters per second. We know from grade 10 that distance is equal to velocity times time. Distance is equal to 1.5 meters per second times 401 seconds. So 1.5 times 401 601.5 meters. We still only have two significant digits, so my answer becomes 6.0 times 10 to the 2 meters, or 600 meters. Now part C says, what is the resultant speed of the cat swimming? So we know she's going to be swimming over at 2 meters per second. We know she's going to be pushed downriver at 1.5 meters per second. So the resultant speed is going to be the vector sum of those two. Now, we have a right angle triangle, and we have the A side, we have the B side, so we can find the C side. So C squared is equal to A squared plus B squared. C is equal to root A squared plus B squared. C is equal to root 2 meters per second squared plus 1.5 meters per second squared. C is equal to root 4 plus 1.5 squared, 2.25. C is equal to root 6.25. So 6.25 root. C is equal to 2.5 meters per second. I'm just off the camera there. So C is equal to C is equal to root 6.25, or 2.5 meters per second. Now, if you were standing on the shore with a radar gun measuring this cat swim, that is the speed you would pick up, assuming you're standing where the cat's going to arrive. So that's that question. Now, we are going to look at this question again, and it stands to reason that there are situations where the cat doesn't necessarily want to be all the way down the river, specifically 600 meters down the river. And if the cat wants to arrive at this location, then she should actually swim at some angle. So if she swims directly across, we know she's going to end up down here. But if she swims over this way while the river pushes her down, she could probably figure out what the angle is and know how to get directly across. So that's what the next part of this is. At what angle should she have headed relative to the horizontal so she makes it directly back to her owner? So here's the scenario. It's 802 meters. We know she wants to arrive back at her owner. So she's going to swim up this way, and she's swimming at 2 meters per second, and we can call that velocity of the swimming. We know the river is going to push her down, so we call that VR at a rate of 1.5 meters per second. So the actual speed will be down here. And hopefully, if the person was sitting right here, then with a radar gun, the actual speed would be what she would be measuring. But now as she swims at 2 meters per second, some of her speed is going to fight that current. So he's going to measure her coming across a lot slower. So the first thing we need to do is figure out what this angle is. So we have, once again, a right angle triangle. We have a hypotenuse, we have an opposite sine, and we have an adjacent sine. So I have opposite and I have hypotenuse. So the sine of the angle is equal to opposite over hypotenuse. The sine of the angle is equal to, so realistically this is VR over VS is equal to 1.5 meters per second over 2 meters per second. So 1.5 divided by 2 is 0.75. So theta is equal to the angle whose sine is 0.75 is equal to 48.6 degrees. I still only have two significant digits, so that becomes 49 degrees. So if she swims up at 49 degrees, so 49 degrees up from VA, she should arrive directly across the river. So the final part of this question really is asking, once again, what is the resultant? And then once we know what the resultant is, we can figure out what we're looking at. So I have a hypotenuse, so I have, let's call this A side, B side, and C side, just to make life a lot easier. So A squared plus B squared equals C squared. In this case, I'm looking for A squared. So A squared is equal to C squared. We take B squared away from both sides. A is equal to root C squared minus B squared is equal to root 2 meters per second squared minus 1.75. A is equal to 1.32 meters per second. And that, of course, is equal to the actual speed. Now, it makes sense because the cat's still only going to be able to swim at 2 meters per second. And some of that, once again, is going to be going to fight the current. So her actual speed is going to appear to be slower. But she's still swimming at the same speed, but this is where the relative velocity idea comes in. We still know that time is equal to distance divided by velocity. Well, the river is still 802 meters across, but now the velocity is 1.3 meters per second. So 802 divided by 1.3 equals 617 seconds, or 10.3 minutes. Should probably clean this up for significant digits because I still only have two. So 620 seconds it would take for her to cross. And that is essentially how we do most of our relative